a completely hands-free experience from REALWEAR. Free your hands.
Chris, the first part of the process we're going to look at is the wart pump. And one of the issues with the pump, which is this pump here, it's pumping some of that liquid out into fermentation.
Yeah.
And this is the type of pump you have. Mm-hmm. And there's a problem that occurs that's called cavitation. Can you explain what cavitation is?
Sure, absolutely. So in breweries, we typically use centrifugal pumps. Those are probably the most used pumps in the world. I think we have 17 of them in the brewery today. One of the challenges you have is we're trying to get the product to market as quickly as possible. We want to free up that cash flow, release those ingredients. We also want to run efficiently so our employees aren't logging extra hours. If you cavitate a pump, that means that you're creating micro explosions inside that pump, inside that actual head there. What happens then is you're destroying your product, so you have a QA issue. So all of a sudden we have a quality problem with our beer, and actually it's damaging that beer. Then secondarily, it's slowing the process down, and so we're actually not getting the process done. So labor cost goes up, those ingredients hold. So there you go.
So we're going to see a cavitating pump when we go to our demos, and we're going to see normally what happens is if that happens, you have to adjust the pump, and that's a kind of a complex procedure. It involves a number of programming steps in the pump controller, and if the expert isn't available who knows how to do that, then you can make the problem worse or go in the wrong direction. We're going to say LibreStream, who's going to show us a better way to solve that problem.
Right.
Hello? Did someone call my name?
No. Hello, Chris. Can you hear us?
Yeah, I can hear you. Hi, guys.
Excellent. How you doing? Welcome aboard, Chris.
Thank you. What can I do to help?
All right. We're going to address a little issue we've been having with our main pump here. So I see that you're standing in our brew house. If you could look to the right, you're going to look at the control panel for the pump there. Perfect.
Yep.
Okay, I see that it's not on right now. If you could turn the rocker switch, if it's on the right-hand side of that support there, and you're just gonna kind of look down a little bit, and you'll see a black switch on the post, and you can just flip that on for me.
You mean this thing down here?
Perfect, yep, that's exactly the one.
You sure? Okay,
I'm sure.
Oh, done.
All righty. Cool, so we'll let the control warm up. Okay, so I'm going to walk you through a couple parameters that we're going to set. Are you ready for that?
I'm ready.
Okay, so what I'm going to need you to do is press the program button.
Can you show me which one that is? I'm not quite clear on that.
Sure, just hold still. We're going to get a picture and circle the correct button.
Oh yeah, I see it now, yeah. Right there.
Sound effects.
Yep.
Excellent.
Would you like me to press it now?
Yeah, just press it once.
Got it.
Excellent. Okay, now you're going to use the down arrow key. You're going to go to P000. Perfect.
There we go.
All right, you're going to hit program.
Press.
Yep. Oops, press it just one time there. You're going to see a single display. Perfect.
There we go.
All right, now we're going to set it to 5. Use the up-down arrow keys to so it shows 5.
All right.
Excellent.
There we go, that's 5.
They're showing 6, so if you could down arrow one time for me.
Oh yeah, my mistake, sorry.
No worries. All right. You want to hit the program button one more time for me? Excellent.
Yep.
All right, so now we're going to set the maximum frequency, how fast this pump's going to spin. So you're going to use the up arrow key, and you want the display to read P134.
All righty. 134. This is my first day on the job, so excuse me if I get it wrong.
You're doing great. I can't wait to meet you in person. You sailed right by 134 there.
134. There we go. Thank you for helping me.
No worries. Okay, go ahead and hit program.
Prog.
All right, so we're showing 66 hertz. I want you to set that to 50 hertz. Go ahead and use the down arrow. If you hold it in, those numbers will go by very quickly.
What are we doing? 55?
50.00.
Oh, yes. Sorry, the memory isn't as good as it used to be.
We might have to talk about some additional testing. All right, you're almost there.
Bingo.
Excellent. All right, go ahead and hit the program button. Cool. All right, now we are going to lock out forward and reverse, so the pump only runs in forward. I'm going to need you to hit that up arrow key so it reads P231.
2, 3, 1.
Perfect. Go ahead and hit program. All right, and you're going to use the down arrow key and set that to 0.
Got it.
Cool. Hit program one more time for me. Excellent. So we programmed the 2 parameters to save them. We're going to go ahead and turn the control off. So that black rocker switch on the right-hand side that we used to turn it on, go ahead and flip that off. And if you look at your screen, you'll see in its shutdown procedure and saving everything, and we should be all set.
Very good. It worked.
All right. Chris, thank you. Welcome aboard.
Thank you very much.
All righty, get back to work.
So-
1 second, and then,
So, you know, one of the things that's, as Sanjay said, we've got a complex network set up in here, and it's actually performing really, really well. But if you think about a lot of times when you're in remote manufacturing locations or remote field locations, we don't always have the luxury of the kind of bandwidth and connectivity we are experiencing today. So, you know, as I mentioned, Onsight was built for these rugged and difficult environments. So what we've done here is we've actually artificially constrained the bandwidth. We've simulated that rugged environment situation. So right now we're running a live stream. Christian, what do we got for bit rate on this roughly?
97 kilobits.
Okay, so we're running 97 kilobits per second right now. So, you know, basically dial-up speed or even a little bit below. Now, admittedly, video's not HD, right? It's not perfect. But Chris, if you can go over to one of the gauges on one of those copper kettles.
Sure, I'm going to go over to the copper kettles here. I'm going to look down at this gauge.
Yep. So we can see that that's a gauge, but we can't read it.
Down now. Oh, yes. There we go.
Because we don't have enough bandwidth. But we had customers, again, back to this idea of evolving the platform. We said, we want the ability to be able to read detail, even if we don't have the bandwidth to produce high-res video. So we still have our picture-in-picture video streaming here, but we always capture a high-res image so you can collaborate, you can resolve, you can identify the pinholes in a weld, or what's marked on an IC, or what's written on a gauge. And I think personal record on this, we were in an airplane hangar in Newark Airport a couple of years ago, and 24 kilobits. We were operating live streaming video, live audio, live data, and capturing high-res images while we scoped the inside of an engine. So that's it on the demo. Chris, thank you very much. We're looking forward to some more patents on beer making.
Thank you. See you later.
Cool.
Thanks, Paul.
No problem. Cheers.